Okay. So what we agreed to do at this meeting was to walk you through where we are with implementing what we call the security development lifecycle. Various people have pointed out to me that you have software development life cycles which have SDL or SDLC as the same abbreviation. So I'm not sure that the name will stand, but we're gonna try, and that's the terminology we've been using internally. More to the point, what I want to do is walk you through what we're doing by giving you a very brief summary in this briefing. It's 8 slides, I think, including the title, and I'll probably spend the majority of my time on one of them, which is the flow chart. We did send around the overview, SDL overview paper to you. That is currently a draft. It's something that we are planning on making public in essentially that form. I have various marked up copies on my laptop, which I'm in the process of going through to get to a final version. So if you have comments on the paper that we sent around, it's very timely to provide those to me. You can provide them to Dave or just email them directly to me. I assume people know my address. If you don't, I'll give it to you at the end of the session. So what I'm going to do today is to first walk you through this overview presentation, and then when I'm done with that, I actually want to bring up the internal resource website that we use to provide to product teams that are expected to execute on SDL before they can ship products, and give you a sense of how we're doing. And then those two things should be a reasonable precursor or introduction to the discussion of threat modeling, which is actually being done by a program manager from the Windows Media Player team. It's one of the teams that's subject to the process. Basically, everybody is, and has been executing their threat modeling as part of the mandate to do SDL. So you'll get sort of a sense at some level of what we're doing here, how we're doing it. I don't think there's much about the difficulties of executing this, but if you prompt me, I certainly can go into that. And the objective is to inform you. If you have feedback, I'm interested in that. I have some specific questions that I'll go through that I'll raise as I'm going through. But that the main thing is what do you think about the process? What can we do to make it more effective? So this, by way of overview, these are actually a subset of slides that we use as part of what we call the VP Roadshow, which is a process of going around to development team vice presidents and their staffs to explain to them what SDL is, what this mandate is, why we're keeping their products from shipping in some cases, and what they need to do to comply. So this is the overview, and it's designed, basically to motivate product group managers to understand the process, understand what their roles in it are, and what we need them to do, and why it's in their best interest. So we really build on that message, on Windows Server 2003 and some of the other products that were done through what we then understood the process to be in late 2001, early 2002. Those of you who don't know how we got into this business, the story is possibly somewhat interesting. The .NET Common Language Runtime development team was coming up to ship version 1 of the Common Language Runtime. This was a team of like 1,500 people. They were pretty close to shipping, and they kept finding that there would be security bugs. These would be found internally. It was version 1. There was no prior version getting hacker scrutiny. And so, they'd get a security bug, then another security bug, then another security bug. And this is a managed code runtime. So the implication of a security bug is that you can escape from the sandbox, or you can get native code to run, or you can access more than you couldn't. And so that was troubling. And they pulled together a team. Some of the security folks from the company said, how can we get ahead of this so that we won't have these bugs continuing to report after we ship? And what came out of that was this notion of a security push. Stop, do nothing but code reviews, security testing. I think that was probably pre-threat modeling, and it was very late in the process. But they did stop. They delayed their release to manufacturing by about 6 weeks. Found and fixed a number of security bugs during that period. Shipped the product, and in the 2.5 years since early 2002, I believe they've had either 1 or 2 externally reported security vulnerabilities against that product. There have been additional security vulnerabilities found internally and fixed proactively in service packs that we've shipped for the product. But basically, in that case, we got ahead of the external finders and have never slipped behind them. Okay? And so that's what we would like to have had happen. Based on the .NET framework experience, and some terrible publicity. Actually, the publicity was worse than the vulnerabilities against Windows XP. We decided to look and see what we could do for the Windows Server 2003 code base that was then in beta, and as a result of that, we did a similar security push, incorporating the development of threat models as we then understood them for Windows Server 2003 in February and March of 2002. Less well known, we also did similar things for other products, and I'll talk about some of those results in a couple of minutes. But at that time, what we meant by the security process was do threat modeling, and we knew that threat modeling ought to be early in the process, but because we were where we were, we did it when we could do it. Do the security push, which is basically code review and security testing, and then subsequently during the Windows Server 2003 project in late 2002, we added what we called a security audit. We now call it a final security review. And the audit, the FSR, is about having an independent team go through the product and say, is this fit to ship? Not, we're going to find all the security bugs and make you fix them, because we think that's impossible or unrealistic. But we're going to find some security bugs, we're going to look at what you did, and we're going to decide on fitness to ship. And I'll talk a bit more about that in the next slide. We also did training as part of the security push process. Basically, everybody would stand down in typically half day training. What I say about the training and this comes to some things that we'd be interested in your feedback. Well, we'll be asked for more feedback. But what we say about the training is that the training wasn't the half day in the classroom that we mandated, but the training was the combination of the half day plus the security push, the fact that these team members couldn't work on anything but security for a month or 6 weeks. And so we felt that that was getting us, you know, some real effect to the classroom training. SDL is a company-wide mandate. If you saw, my view is that any all employees email at Microsoft is a public document, whether it's intended as that or not. And the email that Steve Ballmer sent to all Microsoft employees at the beginning of July talked about the fact that SDL was mandated for products that we release, and that's been something of a help in getting people's attention to the need to implement the process. The way we characterize it is shown here: process, education, accountability. I have a slide on each of those, so I'm going to I'm not going to dwell on them now, but we'll go back and pick up those topics later. And this is just recap. I think I probably pretty much covered this. It has some statistics on it. The interesting thing here, we talked to teams that went through the security push process, particularly some of the, other than Windows, and we say, and the response we'll sometimes get is, well, we stopped work and we did all this stuff and we reviewed our code, and then we shipped and we went back to work. We don't know, we don't know what it accomplished. So this is a snapshot of the accomplishments. Less well known, the SQL and Exchange groups took their Service Pack 3 releases for SQL 2000 and Exchange 2000 and went through the process as we then understood it in the spring and summer of '02 and then shipped. And this is very much apples to apples comparison. Security bulletins, the patches that we release, before and after the releases of those service packs. So we went from 7 security bulletins against Exchange 2000 in the 2 years prior to their Service Pack 3 and 1 since. SQL went from 14 in the prior period, which is 18 months, to 3 in the period after. So, and this is what I characterize as sort of dropping like a stone, and it really is just, it's really just a direct payoff of doing the process, because there's no indication that people have stopped looking. The Litchfields have reported a ton of vulnerabilities against Oracle as recently as Black Hat last week, and I believe that if stuff were still there and easy to find in SQL and Exchange, people would be reporting it to us there too. For Windows, we've done a variety of comparisons. This one is critical or important in our severity rating system against Windows Server 2003 in its first year versus Windows 2000 in the same period. One of the things that we do, you've heard us talk about it before, is change the defaults, and stuff that's off by default tends not to be critical or important even if it has vulnerabilities remaining. And so a lot of the reduction is not only the fact that we've eliminated vulnerabilities, and we certainly have, but that we've changed the default posture of the system so that vulnerabilities that remain are not critical. And one of the things that came out of the final security review for Windows Server 2003 was we looked and we said, you know, the browser has a lot of vulnerabilities. And, you know, we have code reviewed it, we have security pushed it, we have made changes. We're still not completely convinced that this thing isn't going to have new vulnerabilities. So what we did for the browser in Windows Server 2003 was to lock it down really tighter than a drum. I mean, it's not useful for general browsing in the default configuration that it ships, but for a server product, we think that's probably a reasonable trade-off. And that's been a major factor in reducing the number of critical vulnerabilities against Windows Server 2003. That said, old code is a problem. And that's something that we're continuing to wrestle with as a company, and it's something we're going to have to confront in Longhorn. So this is the process description, and this is where I want to spend the bulk of the discussion. Yes, Jeanette. It's all right. It's all right. Okay. Actually, I'm very used to managing obstreperous audiences. I'll get through the presentation no matter what. 20-minute rule waived.
I just wanted to know whether if there was a vulnerability reported in the field due to perhaps the browser then being turned on in the field, and if that's one of the, or would that vulnerability have been reported as a non-critical or non-important vulnerability?
Okay, so if somebody reports a vulnerability against the browser, we have had critical vulnerabilities against the browser in Windows Server 2003, despite the default changes. Okay, and so they'd show up there, you know, if they're in the time window. We've also had external reports against the browser where the patch, the update, is critical for Windows 2000 and XP and Windows XP, and moderate for Windows Server 2003. So that's the payoff, and that really is a payoff for customers, because even though they have to apply the patch, or they may have to apply the patch, they can apply it on a scheduled basis rather than, basically when they get around to it, rather than, considering it a 24-hour or 72-hour fire drill. Okay. Yes, Dave.
Why did you separate 9 months versus 12 months?
It's slidesmanship. These are slides I stole from the marketing guys.
The last 3 months of 12 months have a lot more vulnerabilities uncovered. That's no big deal.
Well, I mean, we track these on an ongoing basis. I mean, it's not really a subject of the talk, but but we had sort of a dry spell where we couldn't, basically we were having some patch quality problems, and so we weren't releasing sort of a representative number of bulletins for a while. I think, as I say, these are just marketing slides, and so they picked it up this way to make the slide look good. I wouldn't pay much attention to that. We do track this. The number is down I can slice and dice some more and come back either next time or even tomorrow and see if the numbers look radically different. My impression is that they don't. Yes, Greg.
My question: do you have any information on customers that unlocked down the browser or just didn't like that change?
If you're running Windows, I haven't heard any groundswell of complaints. If you're running Windows Server 2003 as a terminal server, then basically you have to unlock it. So that's sort of the bad news. Good news is that in a terminal server is an end user, and end user really needs more browsing capability than you have. The good news there is that if you're running on terminal server, typically those terminal server users aren't admin on the box, okay? And so you get some mitigation there too. Place where the browser tends to be dangerous is in home or what we call unmanaged configurations, where you have the combination of unrestricted browser and the user running as admin. So let me talk to. So we had this process that we evolved over a period of about a year and a half, and then toward the and we were mandating things, doing FSRs, stopping products from shipping in many cases, but about the end of last year, fall of last year, we really started to say, okay, we've got to put this on a much more regular and structured basis. And so what we did was to go back. A crowd of folks from the security engineering and communications team where I work. Michael Howard, a key co-conspirator. Michael's in New Zealand this week. Eric Bidstrup from our team is in the back and was instrumental in getting a lot of the processes put in place. So what we did was to say, okay, what are we doing? And what ought we to be doing, and how does that look, and what do we tell product teams that they must do? And basically the document we sent around to you is the summary of that, and this is the one slide wrap-up of what's in that mandatory process. One artifact of the process is that we do have a central security engineering team. It's referred to here as the Secure Windows Initiative team. That's a legacy name. That's where the people who manage the process live and work. Frank Swiderski and Eric and I are all from that team. So one of the things that we do. So we broke the process up into phases: inception, design, implementation, verification. These are the standard lifecycle phases that the Windows division and other development groups across Microsoft have centralized on. At inception, the key things that we want them to do are to understand the process. So we'll actually have a kickoff call with a product team that's doing a new release, or a kickoff meeting with a product team that's doing a new release or a new product from scratch, and say, okay, this is what the process is. This is what it means. These are the places where you have to execute parts of the process to avoid getting surprised when you get to the end. As part of that, we assign them what we've called a SWI buddy, somebody who's typically a program manager from our team, who's responsible basically for holding their hand and guiding them through the process. Not doing the process for them. They do the process. But what we do is provide somebody to answer their questions, review documents or review review material as they're on the way, make sure they're on track. The other thing that comes up at inception in the requirements phase, that there may be security feature requirements that are just things they need to do to be competitive, to be in their marketplace. And so they want to identify those as part of the requirements process. Then at the design phase, there's a set of design guidelines they want that they have to follow. Threat modeling, we'll talk more about threat modeling. Threat modeling does two things for you. One of them is it identifies places where you have to introduce security features to block threats. Okay, so if I'm building a system that has a client and a server component and they're communicating over the wire, then I'll typically have to introduce some sort of a security protocol, an encrypted protocol, to make sure that somebody doesn't sniff or modify that communication on the wire. So that's a case where the threat modeling dictates the introduction of a security feature. The other thing that threat modeling will do is obviously call out places where the code has to be right. If I'm accepting user input, then the threat modeling will tell me that I have to make sure that the user input isn't longer than the buffer I'm copying it into, and that we consider not a security feature requirement, but obviously a security assurance or security correctness requirement. We get those things both, and then the threat mitigations come into the functional and design specs. Do a design review. Identify any additional product-specific ship criteria from the product. Other things that we are in the process of evolving, we have, you'll see this when I go to the website, we talk about security architecture, we talk about trusted computing base, we talk about minimization, we talk about layering. You'll see some discussions of layering and minimization when the hypervisor folks talk tomorrow. We're still in the process of evolving what our standards and requirements for security architecture ought to be. It turns out those of us who've worked on secure operating systems kind of know about that stuff. And a lot of that is being baked into the Longhorn designs. But what do we tell a group in general, whether it's a consumer TV product or an operating system or a firewall, in terms of what they ought to be doing about security architecture? We're trying to be pretty rigorous about being able to provide worked examples and specific guidance before we mandate something that a team has to produce. Talk about that more in a few minutes. Implementation is the coding and testing phase. Coding and testing standards. Primary resource there is, of course, the Mike Howard, Dave LeBlanc book. We are introducing what's called, I'm not sure whether this is a general industry term or not, fuzz testing, basically the notion of providing structured bad parameter testing as part of the test. The other thing we want them to do is to test against the threat models. Are the threats whose mitigation was called out in the threat modeling process really mitigated in execution? In other words, does the code really block the threats that you said you were going to block? Am I doing something wrong?
I'm suggesting the volume.
Oh, you're
a little loud.
A little loud. I'm sorry. Actually, I could almost talk in this room without the mic.
Keep talking.
1, 2, 3, 3, 2, 1. Okay, sorry. You know about the tools, prefix, prefast, something called FXCOP for managed code. those things done during the implementation phase. We've kept the security push for the moment, and there's a lot of argument about whether we should or whether we shouldn't. Security push, is the old stand down from the Windows Server 2003 and other process. Do code reviews, do attack testing, review the threat models because you developed them now at the design phase. Look at new threats. Have there been external reports of vulnerabilities, either in Microsoft products or in other competing products, where we want to make sure that we're mitigating those we're mitigating those threats in the product. Complete the security testing, and the arguments about the security push are as follows. The argument against is, I want to do security as I'm doing the product. It ought to be code ought to be reviewed as part of writing it. Code ought to be tested for security as part of testing it. I'm afraid that if we say we're going to have a security push that is at the end and dedicated to security, teams will only do security for that period, and otherwise they'll let it go. The argument in favor of having the security push is that if there's stuff that you didn't change, it still needs to be reviewed, and that's the time window during which we can make sure you review it. Obviously, didn't change implies didn't change from an older version of the product, so you want time to go back. And this is still an argument that I'd say we're having. The security push is still part of the process. Yes, Martin.
It seems to me like some of the activities in the implementation phase and verification phase tend to merge into one another, right? And particularly the fast testing is something that's very well done in the next phase. The distinction is a bit tenuous to me, and maybe making more integrated would make sense from that point of view.
Yeah, I mean that's basically one of the arguments. I mean that's the argument for not having a concrete, not having an all-stop security push. And I agree that steady state. I think we'll probably do away with the security push, but I may literally be retired before we get to steady state. And so, yeah, Jeanette.
Is there an interest in using like spec training and more advanced annotation languages and coding?
Yeah, the question is use of spec string and other advanced annotation techniques as part of the coding, and the answer is yes. I mean it's not mandated across the board yet, but actually some of those things are being applied as part of the Longhorn process. This is company wide. We got to be able to tell everybody to do this and help and make sure that we're explicit enough so that they can all do it. Yes, James.
Steve, is beta RC1 or is it later than version 2?
No, beta is beta. It's not. It's typically between beta 1 and beta 2.
Okay, so that seems a little too late for security. Why not do it at RC1?
You're reversed. RC1 is after beta.
Oh, it's after beta.
Yeah.
I have a follow-up then.
So there are certain security bugs that cannot be found until you've got a completely working product, right? Because some security bugs require collaboration at runtime with several operating components. You get rid of the security push at that point, you need something because you can't find all the security bugs during implementation and testing.
I think you're correct. We will have beta. We do have testers. We are continuing to test. and they have to be running security tests, whether that's a formal security push or not. I mean, the question is what form will that take?
Well, if you're worried about people seeing the security push and saying, oh, well, we don't have to do security until we get to that point, there are different questions to ask during a security push than there are during security tests or implementation. So, you can do buffer overflow testing on certain components, but then on other components you can't until maybe it's just a matter of distinguishing what type of security testing to do. Implementation phase, what type to do.
I think that's probably right. I'd be interested in talking with you offline about how you characterize those.
But you're making it sound as if they don't do integration testing.
Well, they don't. I mean, we integrate. We integrate as we go. You know that, and so and the question. The formal definition of verification is when all the functional pieces of the software are complete. I believe that's correct, and so you have basically you have all the stuff that you're going to ship, and you're trying to make sure it works together. Yeah, Dick.
So, isn't your security push just the name problem? What's the issue? Is the issue that you don't do anything else? If I called that verification, the system verification, and still did all the bullets underneath it, I mean, that seems like a natural place for them. The
key question. I mean, yeah, but you can do code review, attack testing, evaluate new threats on an ongoing basis. Okay. The key attribute of the security push is everybody stop and do nothing but security, and that's where we get into controversy.
At the system level.
And it's at the system level. Yeah, full product level.
Why is it good that everybody stops and does nothing else? That you're preventing the targets from moving out from under the people who...
I would say it is rather that every component, you have doing it that way. You have assurance that every component gets security reviewed.
But that could be asynchronous.
It could be asynchronous, and that's the counter argument. And doing it asynchronously, the counter argument is if you do it asynchronously, something may get underemphasized or slip through a crack.
What strikes me is there's this presumption that everybody is going to be equally good at doing the security stuff, and I don't believe that. I believe it's good for everybody to know a lot about security, but I bet you have some people on any project team that are much better at this skill than the others, and I don't understand why you want to leverage that. And therefore, if you say everybody stops, that means you're wasting the cycles of the ones who aren't in that really good class. And if there are other reasons that everybody's stopping, maybe there's a different way to structure the work.
Well, I mean, we do structure the work, and even as long ago as Windows Server 2003 push, we did structure the work to take more advantage of those people. Okay, but the thing, I mean, stating the obvious, there's a lot of code, and so getting everybody stopped has the benefit that you get eyes focused on as much code as possible, which is a helpful thing. Yeah, JC?
Yeah, I was part of the Windows Server 2003 security push, and one of the benefits we had because everyone was focusing on security is we could interact with them on the same level. Now, when you talk about specialists around security being available, there were people who specialized in just going around from group to group, helping us understand the right things around security. And so it wasn't like they were just doing security reviews of their components. There were people who just helped everybody on a continuous basis. So if I was to grab a tester or a developer and say, I'm looking for security, diagrams, whatever, and they're working on some code, it wouldn't be very beneficial to me. So having everyone stand down, in my mind, made it easier, more efficient to stop.
Yeah. This is something we're I mean this is something that we're still sorting out. We do have the argument, and probably the places where we have the arguments are most with teams that have the best understanding of what a mature process for building secure code is. And so, frankly, if they abandon the security push, they'll do it. They'll tend to do it because they know what they're doing. But it is part of the process. Key point. Okay, all this stuff is done by the product team with aid, answers, tools, resources from the SWI buddy and the SWI team. Okay, it's not primarily driven by the security engineering team. Much less so than the Windows security push was. The final security review is an activity of the Secure Windows Initiative team. It is a bottleneck. It is not scalable, but at this stage in the process, we believe that it's necessary to do it in this way. And so what the final security review does, the things listed there, look at review the threat models, to get an overall sense for how they were done, and look in more depth at the ones that are most critical. Look at unfixed bugs, and I'm going to expand on that. I think that's alluded to at some level in the document you had, but probably not in enough detail. Teams will file bugs and they'll say this is a security bug, and then they'll either fix them or they won't. They can either not fix it because they decided it wasn't serious enough, or they decided it wasn't, it just didn't repro. It wasn't, on further examination, it turned out to be a bogus report. We want to look at the unfixed security bugs to see, did they make the right calls? Were the not repros right? Were the not serious enough to be fixed right? And then depending on the outcome there, that can be a finding of the FSR in effect. Yes, Dick.
I'm having a little problem overlaying this standard software development lifecycle. And I don't know if it's that everything's captured in coding and testing standards problem. Because I'm looking for a requirements design, implementation, integration, which may be part of the implementation, the test. And sometimes I get this verification of the system test. And so do I just assume that that's done? Everything you have here is security related.
Yes. This is not, this is only, I'm sorry?
I would expect that to occur in the verification phase as opposed to and I'm not clear about what Microsoft uses as verification versus validation. I mean, you're sort of like, I put the whole system together and now I do system testing, stress testing, all those sorts of things. Does that occur on your slide under implementation?
Essentially, all the integration and testing activities that you would think of in a normal development life cycle are occurring as we go, typically from a pretty early stage of implementation. Okay, and the system gets more and more locked in as it proceeds from left to right. Okay, so verification is beta. Okay, and if you've participated in Microsoft betas, you'll know that there, for something like Windows Server 2003, I think there was a beta 1, a beta 2, a beta 3 of progressively increasing locked downness, in terms that there may have been, there will typically have been features added between beta 1 and beta 2. Typically try to avoid that between beta 2 and beta 3. By beta 3, it's pretty locked down, and what we're doing in the release phase, the release candidates, which I can't remember whether you or James asked about, but the release candidates are typically very locked down, and the only things we're changing there are to fix bugs, or including security bugs. But so the system is integrated as we go. We're stress testing it as we go. We're engaging customers in the testing starting in the beta phase, and customers are engaged from then on. And by the release candidate phase, it's typically quite locked down, and the only things that you're changing are things that are bugs, things that are deviations from what the system is supposed to do.
So implementation is really implementation and test in the life cycle.
Yeah, I mean it's a spiral. Mike Howard and I were actually talking about that. It's a spiral rather than a waterfall, and it's and it's pretty aggressive in terms of the level to which you have running code early in the process. Yes, you're right.
Oh, I was going to ask does the scheduling of this allow for iteration so that if you find bugs in the security push or the final security review that need to be tended to, scheduling allows you to go back, say, to design or implementation?
Yeah, certainly. I mean, you'd be really unhappy if you got to release and found something that was a security vulnerability that forced you to go all the way back to and reconsider design. But the ship criteria aren't going to allow you to ship with a critical vulnerability. So, I mean, you hope that critical vulnerabilities are going to be code level bugs where you change a modest number of lines and then retest and ship. But I mean, again, remember my example of FSR, Windows Server 2003 and the browser. We didn't ship the browser in Windows Server 2003 with known critical vulnerabilities. But we knew that there were critical vulnerabilities that we didn't know about. So we took, in that case, I mean, we did take probably a couple of months slip to make a design change that mitigated those sort of wholesale. Okay? So, and that's an example. It's not something that we're thrilled to do from a schedule perspective, but it's the sort of thing that we can do and will do. Right, yes?
How hierarchical is the SDL process? And I've been hearing the words system level, architecture level, but whatever I see in my mind seems to be component level and code level. And I'm just going to echo what James said earlier, when you do testing whatsoever, it's the integration testing which is really going to raise most of the vulnerabilities. So what I'm trying to understand is how hierarchical are the threat models when interactions with other components are considered? How hierarchical is the testing process, the verification process? Most of the real security bugs are going to appear over the interactions, not at the component level.
Actually, so two answers. The threat models do consider the context, and the overall set of components in the system. And I think you'll get a better perspective on that in the following discussion, where you see the interactions of media player with IE and with the operating system components as part of the discussion. The security testing is a combination of component and system level, obviously the final security review is especially, is both component and system level. Just from the standpoint of having dealt with externally reported security bugs, and also having sat at the knee of Earl Boebert 100 years ago, one of the things that we find, Earl used to say that security really is in the weeds, and the security vulnerabilities that we find and respond to really tend to be pretty sort of component and code specific. That may not be all of them, but that is what the state of the art is today in terms of product vulnerabilities. Well, and it's possible that that's the case. It's possible that that's the case, James. Yes.
If I understand correctly, these are phases, and what you mean by that is that the stuff to the left is all done before the stuff to the right starts, or how much do you allow for interleaving? Say, if someone wants to do the implementation before they do the design, is that okay?
It's not. You ought to no. You ought to have design before you have implementation. Although note that version 8 of a product is de facto going to have implementation before it has design.
Sure. Now, one exception to that I would suggest is that you should in fact encourage the verification stuff to start before implementation is done.
And
it'd be good to have some of the attack testing
and we certainly do encourage that.
So even if there's a distinct security push at the very end,
Yep.
you might
Yep. And the question is whether we can do away with the security push, and the answer is not soon. But people are clearly doing code reviews before they check in. Virgil.
Steve, have you found in the verification phase any design? Let's say something like quota verification on resources, on resource usage. You completely forgot to verify the quota on a class of resources, as opposed to not doing a parameter check correctly. So have you found any of those?
We do. Those do occur.
Yeah. Do you have any examples as to what type of things, what type of designers you found verification?
It's primarily legacy stuff. I'll give you an example without specifying the product. It's not one I think you'd have heard of, but we did encounter a product that was doing client-side authorization to a database. Okay. So if I assume, if I, you understand, you understand, everybody with me, and so in other words, the client is outside the client is outside the security perimeter. It's doing the authorization check and then passing, basically an authorized or not to the server. This was basically a legacy product. And it was bad and it was painful.
So anything else other than legacy that comes to mind? And I'll tell you why I'm asking. That's what leaps to mind offhand. It's not common, and it's certainly not something that we find with products. Where you'd expect security to have been a focus for some time. The other thing, what was the point I was going to make? No, go ahead. I'm sorry. So the reason why I'm asking that we always emphasize that you should start security verification, as Martin mentioned, in the design phase, but if your experience has been that you found absolutely nothing in the design phase, in the verification phase that pertains to the design, maybe our philosophy and our experience, and it's invalidated by yours.
Well,
Why do things early when you don't find problems early?
no, I mean,
So what's the
the thing, one of the things, I know what I was going to say, and in fact it's germane. We don't, finding bleeding wounds finding design bleeding wounds at the verification phase is unusual, particularly in products where you'd expect them to have been paying attention to security for a while. What we do find is that we have arguments about attack surface. Okay? So what's the security by default? How exposed is the system by default? How do we make the trade-offs between usability, feature discoverability, and security? Those are things that come up pretty routinely.
So that tells me that you do quite well in the design phase already. You don't find many design.
I'm not going to oversell. I want to manage time just a little, if I may. Final security review. Key thing about final security review is that key thing about final security review is right here. Checkpoint Express is our internal yes you can ship system. If the SWI team doesn't sign off in Checkpoint Express, the people who put your bits on the web or on the or onto CDs won't, and so that, and then we do ask people to consider security response as part of the development process. We assume that vulnerabilities will be found. We want them to be prepared to deal with them. Let's see. One of the more interesting factors that we have to deal with is what we call reusable components. The internal jargon for that is giblets. Think the bag of stuff that comes inside the turkey, and if you're shipping some other component, we're asking you to be responsible for being sure that it's secure and that you know how to service it. We've been burned occasionally on that, as recently as a few weeks ago. It's an ongoing problem in a big company. Particularly, in a big company and in a distributed industry. Okay, education. We have mandatory training. It's a 4-hour live course taught by Mike Howard. It's ongoing. There's online training option, especially for remote sites. That is actually live now. We're rolling out additional and specialized training during this fiscal year. We're tracking training compliance across the engineer population. One of the interesting things, in the interest of time, I don't want to get in depth with this, but if somebody had, there's a lot of interest in being able to say, if somebody isn't competent at secure coding, then they can't work on, they can't be promoted, they can't work on security critical components, they can't work here, et cetera, et cetera. If anybody has a formula for an objective test for saying yes or no there, I'd be interested in hearing it. Fred.
So I understand, or I think I understand what you're doing in training, and training is the right word.
Yep.
But as you know, there's like a whole other clique of abstraction which has to do with principles that don't have obvious characterizations of coding so much. Like what you fill all the 12 other weeks in your security course with. And until people get that stuff, there are going to be these higher level flaws in the architecture design. Is it your hope that by having security experts always affiliated with projects you'll avoid this, or is there some hope to ramp up
to education so that you're raising the general level of sophistication of designers? What's the plan?
B. I mean, we do hope we do hope to raise the sophistication overall, not of the entire population, but at least to have security, at a deep understanding level and at a design and architecture level, distributed throughout the company enough so that we can be doing a better job of designing secure products.
Is that by hiring or by education?
Both. I mean, we'll hire where we can get people, and we also want to do more education as we go.
Some kind of nutrient as far as something like this.
Well, I mean, what I've said is that that we're going to do more with training and education in fiscal year 05, which started a month ago, and so this is something that we are attempting to do.
So does that mean at some future point this group ought to get a look at your curriculum?
Yeah. I think that's something we could do in January, and that'd probably be that'd probably be timely, because there'd be some more stuff done, and there'd also be some plans for more yet.
I think, to be fair to what Steve Carlon said, is you're asking for a generic change in culture of the design architecture. Whether it means to or not. And they are right now security, and I think this. I mean, I was going to ask this question anyway, but there's engineering excellence
Yep.
theme that Amitabh is really kind of close.
Yeah, I was actually thinking that we ought to get Amitabh in here if we could in January to try to talk about the some of the focus on architecture for Windows, some of the things that they're doing for with more structuring on Longhorn, and basically get an update for that. I say that, I'm not sure whether we'll be able to organize that, but that ought to be a goal.
But even if we can't get him here, you or someone can explain what it is, and
Right.
then show how the security is
Yep.
overlaying that, the security SDL is overlaying that.
Yep.
Because that would more directly concern.
Yeah, I think. I mean, it's a broader issue.
We're going to see in January or March, there is Mike Howard's book.
Well, no, you're going to see more than Mike Howard's book.
Well, and this book too.
Well, right. I mean, you'll see those things, but I think we may see some more. You'll see some more things in March. Oh, I'm sorry, Dave.
I was waiting until you were done. All right, I'll wait till you're done.
Okay. All right. So this is this pretty sensitive chart. This is basically high level tracking these are the metrics that we're asking teams to track and report quarterly in terms of products under development and how are they complying with the process. And the aim is to be able to see these at the senior management level during the quarterly business reviews. How you doing? Did you complete your threat models? Did you review your Pry1 code? Did you cover threats with the test? So on. You can read the column titles. And so really be able to drill in at a product by product basis. Obviously, any given product is not going to be populated in all the rows in any given quarter, but the objective is to say we have some metrics, the teams will track them, and we will be in a position to say, are you complying with the process or not? The process isn't static. We quote update as needed. We introduce new requirements on a twice yearly cycle unless something comes up, that's urgent, in which case we introduce it. And we try to give people some time with requirements as recommended before we zap them with it. And some of the things that we're updating, I talked about training and education, security architecture and trusted computing base is something. It's interesting. Scott and I were talking about architecture and security architecture. I'd be, if there is something that some of you can recommend to me that is sort of a concrete example of how to write a security architecture for a pretty arbitrary product or component, I'd be interested in having that reference as a way to, as something we could provide to teams for guidance. We've gone back and forth. What's a trustworthy computing base? How do you measure your attack surface? What's your layering? How do you divide into components? What are the highest level threats that you're trying to mitigate? Those are questions that we think go into a security architecture. But this is something, I feel like I'll know it when I see it. The Multics design analysis or the VAX SVS design analysis document from 1981. Things that I may have seen or written but don't necessarily have copies of anymore. What are the broader examples? What are things that go beyond operating systems? What do I tell a game or a compiler that they're to worry about? And how do you do that? Attack surface, we're a little better shape there. Yes, I'm sorry, Nira.
That's a really simple question.
Sure.
What's the definition of an architecture?
Well, if I had to do it, what are I guess the two things that I would look for are what are the high-level services or interfaces provided, and what's the internal structuring of the system or artifact at a high enough level to give some sense of how it's built or how it's organized.
Curiosity is if the different people working on development, testing, verification all have a similar conformal view of what architecture means.
I'm sorry?
I'm just trying to understand if all the developers, testers all have a similar conformal view of an architecture.
I wouldn't guarantee that they all did. This is something, where we as a company are putting some emphasis now, and I think the understanding is evolving.
It was worthwhile to discuss amongst all of us to come up with some generic definition which we can all look around. They're all consistent and perhaps not can be advocated now.
I think that'd be a useful input, a useful contribution. Let's see. Let me just go on because I want to do one other thing. We are privacy requirements. It turns out that privacy is both a business practice. I'm going to get in trouble with Peter or JC now. Privacy is both a matter of business practices, but also a product attribute. Things like the product shouldn't phone home without user consent. Things like the product ought to protect personal information as it deals with it. Some of those are, and to the extent that those things are product attributes, we have, until recently, even to this day, we have a separate process for reviewing product privacy attributes and ensuring that personal information is handled properly. What we're in the process of doing is integrating privacy into SDL. so that there'll be a single process, single set of requirements, single FSR, basically cut down the burden, provide a more robust process and also cut down the burden on product teams.
You're not in trouble. I'm going to say the training's worked wonderfully.
Well, okay. That's fine. But
Yesterday, in Scott's talk, we talked to a question about reliability. I have the sense that there are really three parallel tracks, if you will. There's a security track, a privacy track, and a reliability track. And I think they'll all be merged into this process, and we could just rename, like back to your long graph, we could just replace security with trustworthiness. And the book might get a little bit bigger about what you do, but that's essentially how it's
I'm less certain about reliability, Fred, just because we're so much farther along on reliability, in terms of doing the things that improve reliability and demonstrating results there. Certainly, security and privacy, to the extent that they're product attributes, our plan is to merge them into a single life cycle. And reliability is a discussion that Scott and I continue to have.
Part of it, really quite frankly, ties to the standards discussion that's happening in the words. But I haven't set a standard for you.
Yeah, but we have a set of product requirements that we're enforcing now, and I expect that work to be done fairly quickly, certainly by your next meeting. Okay. Well, okay. So the other thing I wanted to do, let's see, Dave, you had a question that you were holding. You want to go now?
I think I had two. One was, if the old-fashioned software development process was, say, 24 to 36 months, what would you say a need in terms of latency or more manpower the security push adds to that process?
Oh, I don't think you can really measure. I mean, the duration, the duration. So let me talk to you about Windows Server 2003, okay, which is something I know quite a bit about. We took about 2.5. The actual security push. Everybody stand down and do nothing but security for Windows Server 2003 was about 2 months. We actually did finish at different times for different teams, but 2 months is a good estimate. What we were doing in the security push was not fixing bugs, not making all the changes that we had identified as necessary, but primarily filing bugs, identifying the changes and marking them in the workflow system to be changed later. There was probably another 1 to 2 months of recovery in terms of making those changes and getting back to where we would have been if we hadn't bothered. Then in addition, I think there was probably another couple of months of damage to the schedule done by the final security review, especially the IE lockdown and a few other things that were done at that point. So I think that Windows Server 2003, which shipped in April of 03, probably would have shipped in late 02 had it not been for the security-focused efforts of the process. I think that's a worst case, A, because it's a big product, and B, because we didn't start planning any of this stuff until the beginning of December of 01. And so, there were a lot of catch-up activities that we're just smarter about. Is it free? No, but I doubt it's 6 months. I doubt it's 6 months. And certainly that's as big a product as we ship. So others less, better integrated less. It's probably the best answer I can give you.
That's a good answer. The second question was whether you have a feedback process on the security development lifecycle. It seemed like the flaws, what do you call them, critical and important flaws that got through, whether maybe you already do this, you revert to engineer and ask the question, well, how did that happen? And what would we, like the 9/11 report, what would we have had to have done to make that not?
Yes, and that can go, and that can go into recommendations for design for as I said, a lot of the vulnerabilities, the bugs that we find are code level. Actually, thinking about that, there's probably some exceptions, but we do analyze. There is a guy in the SWI team who one of his jobs, one of his specific responsibilities, to take every security bulletin bug and understand where it came from, publish a report about that to a broad internal security alias, and then make process change recommendations as necessary.
I just find things like the risk column and the ACM. I think engineers find those things really fascinating. So I think it's one thing to talk about the principles in abstract, but if we talk about what got through the system, people seem to pay attention to that. That might be
no, we do publish that in turn. We don't publish to risks, thank you very much, but we do publish internally down to the level of code diffs. Here's what it was, and here's why it broke. Okay, I want it. Huh? I want to just show, give you a sense of this, of what the, what the internal resource is that product teams have. There are a number of resources here that we provide them. Let's see. This is the. Let's see what required tools is.
On the public net, or is this internet? Sorry,
it's internal. What do you say, Dick?
Only on your laptop.
Only, right. Right. No, this is an internal website that our team maintains. So this is compiler version requirements and a compiler transition requirement. GS flag, which is the runtime buffer overrun protection. Safe string handling with library with specific version information. Middle, that's the RPC interface definition language, and the robust flag, which is aggressive parameter checking on RPC. Prefast and prefix, an Office variant of prefast that they've mandated that is somewhat more restrictive in some areas. Managed code compiler versions and the managed code scanning tool, app verifier tool, and then 64-bit. So that gives you a sense of the tools that are mandated for use in products. And again, we'll ask them at FSR, did you use these? And if you didn't, you get told to go back. The phases, a little bit of a breakout of the requirements that I was walking you through. Document is a Word document version, somewhat more specific in terms of internal resources and web links than the document that you saw. Licensing source code. This is back to my comment about giblets. If we license third-party code, it still needs to meet the requirements, some guidelines for how to do that. Boilerplate about mandates and so on. So that's the sort of resource that you see if you're a developer at Microsoft or a program manager, a product unit manager, what have you. That's the sort of resource that you see if you if you're starting to build a product, heard about this stuff called security, you want to know about it. How did you find out about it? Well, because there was mail from Mike Nash to basically every development employee in the company. There also mail, also the Ballmer mail, also mail from Mike to vice presidents, and then I and some other folks cycling around through the company briefing vice president staffs to make sure that they're aware. Jeanette.
So how much buy-in is there?
How much buy-in is there?
They've gone through the training. They know that maybe there's even performance evaluation tied to this. Are you getting?
I would say there's a lot of acceptance. The places where we still have surprises and maybe less buy-in are in products that nobody in this room has ever heard of. Okay, it's a big company. I don't even know how many products we ship. I mean, we did a list of the products that had shipped over a year as part of a presentation, and it was like 15 or 20 pages at 20 products per page. Okay. For some fiscal year. So we ship a lot of stuff. If you talk Windows, if you talk Office, if you talk SQL, if you talk Exchange, the things that everybody's heard of, there's buy-in, end of story. Okay.
It's in the CPE, isn't it? The SDL implementation.
Yes, I mean the metric. It's part of the customer and partner experience mandate for the company, basically the customer satisfaction mandate for the company, and that's that funny spreadsheet I showed you is actually a CPE metric for business groups. I didn't want to inflict all our internal process on you.
Just to put that in context, that security as well as privacy is one of 14 components which determines 50% of the variable compensation for the top 60 people in the company. So you're right. I mean, you still need to get it into the process, into the middle management, into the actual guts of it. But at some point, the top 600 people are accountable for that.
I think that's interesting. But what I actually also meant was sort of a psychological buy, in the sense that people will really like it.
So the context shift is what you're looking for.
Yeah, I mean, we're.
They feel good about doing this. They feel like their product is their product is better because it's more secure, more reliable, or more private.
I'd say one of the things that we need to be doing a better job of is communicating stuff is communicating the benefits. Okay. I mean, that's something that I sort of have as a personal objective over the next year, maybe to work with Scott and his team, not just to recognize the people who are developing the process and mandating the process, but also to recognize the people out, in the product groups who've taken this stuff to heart and really done good work with it. I mean, frankly, I was in a class with a guy from Exchange, and Exchange, just this wonderful story. The slide I showed you, the vulnerability rate dropping to nothing. Well, he didn't know that, okay, and that's bad, and that's probably the fault of people in this room, people in this room with blue badges who need to do more to recognize the folks from product groups who are really taking the lessons to heart and making it pay off.
Anecdotally, though, on the engineer level, you know about conference teams and stuff we're doing over in research. There have been some guys that have maybe jumped from research back into product groups that once they were exposed to the processes and seeing everyone else making them do, number one, it's a shocker to them. Number two,
if they're truly interested in doing a good job of software engineering, once they realize the mistakes they're making, they're glad they understand that, and then they pull it back in. Because it was Jay Beavers. Jay Beavers came back over, and he goes, they told me they're not going to let me touch code for 6 months. And I thought, he said, I thought that was absolutely bullshit. Until I saw what I was doing wrong and the stupid metrics that I'm no longer being able or allowed to do. And he says, at the end of the day, I know I'm writing better code as a result. Now, that's just direct anecdote. He just stopped me in the hall one day and told me that, knowing that, I was involved here. So, I mean, there is definitely uptake from individual engineers that appreciate, in many cases, the opportunity to figure out what they're doing wrong.
Well,
Right.
all the components where you have tried the SDL process and bugs still sneak by, do you have a feel what part of the process you would like to enhance or ramp up?
The biggest. So I'll give you two answers. Let me be real. Let me just make a meta comment. I'm being very frank with you guys, okay? And I'm saying things that are super sensitive here. So that said, it's legacy code. It's old code. I mean, there's nothing about the process that doesn't work. It's just making sure that the application is uniform and universal. Yeah, stuff will still break through. 3 years ago, nobody was worrying about integer overflows leading to exploitable buffer overruns. So that wasn't in the training. It wasn't in the code review guidelines. We didn't put enough emphasis on it. People found out how to exploit those, and we got burned. Okay. I've come around to the view over the last 20 years that computer security is more like crypto than it is like mathematical proof. And that's one of the reasons, is because the attack models change, and code that was secure 10 years ago isn't secure today. That will happen. Doing research and doing experimentation and stuff will change that. But by and large, I think the process works, and it's just getting over the hump of universal application. Greg.
So, when a new product comes out, or it's getting ramped up, is there a push to use managed code?
Yes.
Okay, and so that's...
Yes.
Is there any chance of revisiting old products?
Over time. I mean, certainly more of Longhorn will be managed code than XP. Yeah. Yeah. I'm sorry. Yeah. Lori.
Yeah, so I was wondering how much usability issues come into the SDL process, and looking not only at things which create specific bugs, but more at instances where user expectations match what's really going on. So, for example, setting file permissions. It's not a bug that they're set wrong, but users think that there's one set of access in place when in fact it's something else. That is a factor. It is something that we include in the training. It is something that some of the user education and user interface groups have focused on. We think we did a better job, for example, in XPSP2 than in XP. A lot of the dialogues are changed to try to help people understand the consequences of what they're doing, and we're continuing to focus on that.
Let me dive in real quick here. If you want to keep asking Steve questions while we're doing the setup for the next round, that's fine. But we want to get Kevin up here so we can start looking at the next portion.
Yeah, I thought